it's been made stateless, and it's fairly distributed and fault tolerant. Now this is now we have established this is not a real MVNO. So basically, what we do in order to bill our customers is working with this TGS static tab format James mentioned before too, and build the clients. So and then I got to mention voice over LTE support is coming. It's not a part of the CPMNO product as is, but we are working on being part of a test phase, and it's going to be really cool. I really want to do AMR wideband and HD voice and great call quality instead of the good old G911. So yeah, let's start build something. Basically, we started building this in two streams. We have the infrastructure stream, doing data center, doing all sorts of VM and hypervisor stuff, and then we have the development team doing the code parts. One of the things we did infrastructure-wise was to virtualize everything. On the old platform we had, everything was run on bare metal. Even Freeswitch was run on very large compute nodes, and really had way too many cores available for doing what they would. So we had to build a somewhat well-known scalable unit which we could load test and be sure of could handle, let's say, 1,000 Erlangs, which for us translates to roughly 50,000 subscribers. And then basically get rid of ancient networking technology, all this layer 2 stuff, LACP, link redundancy, all this. It's really a hell to troubleshoot. So that we fixed. So we made a layer 3 spine leaf architecture, and this is something I've really grown to like. And I really like open networking, which I learned about reading on this. So basically, this is layer 3 all the way. It means everything is IP based and routing. No shared address space. No big prefixes to mess up things. So once if we lose as one of our spine routers, we basically can reroute traffic within milliseconds to either a provider edge router if we have upstream traffic, or one of our leaf nodes below. And all of this is really easy to connect and manage, because a lot of work has been done in the data center space regarding the border gateway protocol used for this peering. So we can use BGP unnumbered, which is basically IPv6 stateless linked local addresses. You don't have to configure anything, and then configure your routing daemon to say peer with whatever is on interface on switch port 41, and bam, you're up. Linked local address is advertised and reachable from the internet or whatever. It's really a nice topology. Then we built some new compute nodes. Again, because of the spine leaf setup, we are treating our compute nodes or hypervisors as a leaf switch, which means we have a routing daemon to do BGP. We have multiple VRFs for the voice part, and for the public internet part, we are performing source net for whatever has to reach the public internet. And then we have the possibility to do a BGP pairing with VM guests, which is really valuable for our Kamailio and Freeswitch instances, and we can move them around from hypervisor to hypervisor without reconfiguring anything, because they have their own IP address within their own, you can say, containerized or closed enclave. And it's, again, because we're using BGP with bidirectional forwarding detection on top, we have fail over within, I think it's 100 or 200 milliseconds. And all of the infrastructure is basically controlled by Saltstack, which I don't know if some of you know that, but it's similar to Puppet or whatever there exists out there of tools. One of the things that makes Saltstack really cool for us, it's asynchronous, so we can basically deploy configs to all of our 15 Freeswitch instances at once. And of course, once you're doing that, and once you're doing this DevOps thing, you really have to be sure you're doing the right thing, because if you deploy to 15 instances at once, it also means you destroy 15 instances at once. So, but it's Python, it's Jinja, and it's YAML. So what I've put on the slide here is basically what it takes for us to spin up a new site of hypervisors. We don't have to do any special config for your hypervisor. It's just spin up. Basically, salt, hostname, state apply, and bam, it's up. It takes like, I think it's 3 minutes to deploy a hypervisor. And it's all based on templating and the 7 variables in the top of the section. So it's really cool. So yeah, the infrastructure is in place, and we did some battle testing, and we actually deployed the old voice platform, the old code, to the new infrastructure in order to make sure it was working. And that's what we have running live of one of our sites right now, and it's really stable, and it's all based upon open source components. Everything from the hypervisor based on Debian to the routing daemon to everything. Even the interface manager is based on open source. So the application. Some of the graphic has messed up here. It's okay. So what we have in the gray box is basically one of our application parts. It's the stateless, scalable artifact we have. Everything outside of the box is basically interconnected in one way or the other. We haven't really gotten to remake them yet. So basically, a call reaches the Freeswitch, and we have this event socket consumer, which is an inbound ESL connection into Freeswitch, just listening on every single event Freeswitch spits out. And that's, I mean, have you ever done a TCP dump on an event socket connection? Because it's like megabytes of clear text dumped for a single call. It's crazy. And then we have our call handling application, which again has an inbound ESL connection. And both the ESL consumer and the call handling has a connection to a local Redis database, which we're also using as a message queue in order to guarantee ordering of the events from Freeswitch. So basically what happens is the ESL consumer listens to Freeswitch, gets an event, pushes it further down to the Redis message queue we have implemented with a Lua script within Redis to make sure ordering is safe. We tried with mod AMQP in Freeswitch and quickly discovered we don't have any guarantee of ordering of events, which really can be a problem if you're going to be stateless the way we wanted to build this. So. And then we have the call handling application running a 10 millisecond loop, forking new events from the Redis message queue and acting upon them. If anything has to be done to a call, it'll use the event socket connection and send a command to Freeswitch, or even publish a new event if we want to just let other parts of the system know we are doing something. Then we have some global call state, which is what we set out, one of the pains we set out to fix. And it's proving very valuable once we are using our API to do call transfers, for instance. We can look up in the call state database, see what Freeswitch actually carries the call, and that the API connect into the Freeswitch and send an event. Basically send an event consumed by the ESL consumer and then acted upon by the call handling application. And then we did some nifty things about file handling, because I mean, you want to record audio files, you want to playback speaks, and all of this we have saved in an object storage. We are basically using Amazon S3, and we made this small proxy capable of being it's basically a web server, and from Freeswitch we are using I think it's mod curl, where we can just put a file into the file handler and it'll make sure metadata is written to the database and the object is stored into S3, and also the other way around, we can stream through through the file handler, can stream object from S3, and then, of course, at some point, if you are not cleaning up all these recorded calls you have on your Freeswitch instance, you're missing a lot of disk space. So we have a file remover service to clean that up. All of these dark gray boxes are written in Node.js, which is a particularly useful language to use for such an event-based system. It's virtually idle, I think 98% of the time. So it's really powerful. And one of the things we set out to do different this time was to make sure we wouldn't introduce a lot of dependencies we didn't have any control of, because when you're writing Node.js, it's really easy to just write npm install -s lodash or async or whatever. So we really tried to set out and write clean JavaScript without too many dependencies. And I think in this mono repo we have made, I think we have like 14 dependencies, external dependencies in all. So that's really a nice thing to have. It gives us comfort, and it gives us full control of the code base, and we know there is no one out there in some abandoned project who gets, somebody can get maintainer rights on some abandoned project and basically put unvetted code into our code base. Another thing we are doing different in this new voice platform we're building or have been building, is we are treating every single call as a conference. I thought it was going to impose a lot of CPU time on the instances doing this, but actually it's not that much more from what we can see. So it's basically mod conference in Freeswitch, and it's an internal representation of the call in our call state database. So what we do is once a call reaches our platform, we will make sure to make basically a one-party conference, and then we'll just add members to the conference as it's necessary. If we are doing attended transfer instance, then we of course add the B party to the conference, so we have this two-party conference, which is a regular phone call, and then an attended transfer is really just mute one of the parties, add another party, let them figure out what's going to happen, and then kick out whoever's not part of the call anymore. So it's really simple. And the main loop of our call handling application makes sure that we are not having one-party conferences hanging once we are ending calls. I guess that's one of the fears everybody has when working with voice calls. That is, when you all of a sudden end up with having one-legged calls and you don't have teardowns immediately from one way to the other. So it's really cool, and it's actually inspired by a talk. I think it was Netflix who gave the talk at ClueCon a few years back, and it's something we've been really intrigued by since, and it's really nice to see it work, and it has really given us simplicity in the implementation, because the old call transfer implementation was very, how can I put it lightly, special. So another thing we are doing, and I was forced to tilt this, so I hope it serves for illustration anyway. We are doing a concept called call graphs for our calls, which means we are basically passing the provisioned state of the subscriber into a graph. It's basically, and we can export it into a dot file and visualize it if we want. So it's a really cool tool for troubleshooting call flows too. So what happens here is the outbound call graph, we always generate two graphs for a single call. We have the outbound graph from the caller and the inbound graph to the callee. So this outbound graph basically has a bunch of global nodes because this subscriber has enabled call recording and has attended transfer enabled, and a few other features requiring a global event listener. And then we basically start the call and move into add conference member, as I mentioned before. And adding a conference member may or may not succeed. If it succeeds and the call is answered, we'll add the other channel into the conference. We will start a recording. We will eventually park the call once someone hangs up, and do some cleanup. And of course, all of this can be circumvented if the call is not answered. So the inbound graph is way more complex because most of the features people have on their phones are when they are receiving calls. And it's also when you're receiving calls, things may not go exactly as we wanted them to be, because you may have voicemail enabled, or you may not be answering and you do not have voicemail enabled for this particular scenario, and a lot of stuff can happen. So it's a way more complex graph, but it's still a very easy concept to grasp once you start developing it. And also, every single of these boxes down the graph basically shows, here's an event, here's something we are reacting on, here's something we are publishing further down back to Freeswitch to process. So everything in the transitions in this graph is basically can be handled by different of our different call handling applications. So that's what we mean by having stateless. We can deploy basically mid-call and have the graph being continued by another instance of the application. I just once again want to really point out that this is really clever from our developers, and it's a very, very nice troubleshooting tool to see how the call have progressed or should have progressed. And it's of course requires some work in parsing the configs and building the graph. And the graphs here are persisted into the Redis data store too, so it's not like it's recalculated on every single event handling, but it's stored for the duration of the call. So we're building the graph once we receive the call. Once we receive the channel create event from Freeswitch, we are creating these graphs and storing them in Redis, and basically just looking at them every time we handle an event for this particular call ID. So yeah, let's deploy this without any of our customers noticing, because this kind of has to be a big bang release when we are changing the engine while the car is running. So yeah, how to do that? We tried. We had test environments. We have QA resources working on testing this, testing known scenarios and unknown scenarios to the developers at least. And it all turned out fine. It worked. Everything worked in our closed test environment. We did stress tests. We stress tested Freeswitch because we had we had this feeling that doing conferences would be very CPU intensive, and that was luckily not the problem. So we felt pretty safe. We felt we could deploy this. It's going to work. We looked each other in the eyes and said, yeah, this is going to work. I mean, we've tested it. It's solid, and we've kind of sorted out all the issues we saw along the way, except the morning we tried to release this. Shit just went downhill. We have this fantastic database called CouchDB, which is clustered, and we had made sure to replicate all of the production data in a continuous replication to our new site we have built for this. And somehow, I don't know, it just spiked to 100% CPU on all 5 database nodes, and it stayed there for like 3 hours after rollback. So, yeah. That was intense, and we kind of discovered it was due to a new query language introduced in CouchDB called Mango queries. So our developer fixed that. And we, in the meantime, from the operations side, implemented a stress test towards CouchDB. It's a simple HTTP API towards CouchDB, so we could basically just take a HTTP load test tool and just hammer it. So we did that, and it was fine. Everything was fine. So we redid the tests, and yeah, everything was good. Okay, let's deploy again. So meet up morning, very early, and bam, all 5 instances, 100% CPU for like 12 hours after rollback. Okay, so that's basically where we are now. Some kind of backwards compatibility is ruining our deployment, and now it's summer and it's vacation time, and we cannot put this into production right now. So what we're going to do once we get back in August is to make one very, very large CouchDB instance and skip all these cluster parts, because it seems we have like 1 gigabit per second inter-cluster communication on the database nodes, and that's and we are really just doing reads from the database, so it's not making any sense. So no more cluster, done with that. So we're just ripping out one of our hypervisors and installing CouchDB instead. That's going to be the plan forward. Yeah. So apart from that, what's next then? We really want to do WebRTC calls. We really want to be able to anchor calls in Freeswitch and have them delivered towards our apps, so you don't need to have any cell service, but can have Wi-Fi or whatever. And we really want to be able to send calls directly towards browsers and have some sort of intelligent routing to see if you are available or not in the WebRTC space. Then we want to do voice over LTE, as I mentioned, and then we really have to revisit our notification services, because that's also part of the 5-slide diagram I was showing in the start. So it's basically what we need to fix next. Yeah, I hope it gave you some sort of insight into what we've been puzzling with for the past year or so, and how you can build a telco-grade voice platform entirely on open source.
Brilliant, thank you. I think we have at least one question. David.
So I have a list of questions.
Sure.
Well, first of all, what was the difference between SBC versus Kamailio? What were the two different, what was the functionality purposes, and what are you using for SBC as opposed to for Kamailio?
So we are not using any SBC at all, actually. We just having Kamailio being a router or a dispatcher towards our backend Freeswitch servers. But TDC, on the other hand, has an SBC on the border to their network, which every single interconnect is connected to. So it's not because we want to do any sort of topology hiding or anything on our end, but it's because we may not see what's within the core network on the other side.
Okay, what did you mean by that your entire system is stateless?
It means this call handling application I mentioned, and all this graph, these call graphs, and the way we handle those are basically we only do one event at a time. From event to event, we are not persisting any data in the application, but persisting outside in a Redis database, so the application itself can be redeployed or moved to wherever.
Next, QVM Kamu versus containerization, which seems to be what's hot. Why did you go with that? Virtualization on the hosts versus deploying microservices. I know you mentioned microservices in the beginning that you was originally done wrong.
Yeah, so we actually, a year ago, we had a pretty good idea on we wanted to do Kubernetes and move towards containers all the way. But then we really just discovered the tooling we have in Saltstack makes us capable of deploying new VMs, starting new VMs, and also we have a more controlled environment within a VM than we have in a container, and it's not really, we're not really there where we have the need for containers and spinning up and down containers all the time. So operations-wise, it's simpler for us to use VMs.
And last one, I'll let someone else talk. Why are you doing everything through mod conference as opposed to just using the built-in functionality?
Because it makes it easier for us to do advanced call features like attended transfer, direct transfer, and possibly also we have a queue function where you basically add people into a conference once you reach the end of the queue, and you get this ability to have multiple parties in one call, which was one of our very limiting factors in the old platform we have.
So if you go to 302, you interpret that and then bring in somebody else into the conference as opposed to just doing a transfer.
So we're really not getting any 302s because everything we get is from the mobile network, where this is, I mean, the zip functionality is very limited in the translation from SS7 to zip. So we don't get this sort of communication. So we do it from our apps and through APIs instead. But yeah, you could just as well react on a 302.
Any more questions around the room?
Hello, thank you for the talk. We saw that in the picture that you were connecting multiple Freeswitches to multiple Kamailios.
Yeah.
How are you doing this since Freeswitch only supports one-out-one proxy? So
basically what we're doing is we don't have any registrar or anything in Freeswitch. It's basically a dump Sophia profile, listening for whatever comes in and replying to it. What we do is once we are handling a call, we are just dialing, once we are doing the outbound leg, we are just proxying that out through the Kamailio we got the inbound call from. So you just adjust to every call. Yeah. So they're basically on the same Kamailio, and then they are load balanced to the SBCs from Kamailio. But from Freeswitch, it's really just return to sender.
Okay. Nice. Thank you.
I think that's probably all we have time for. We're sort of cutting into lunch now, so thank you very much.
Thank you.
So lunch is from now until